Alright, Chapter 7, Lesson 2, Prime and Composite Numbers. I'm not going to do a lesson recap because the lesson's pretty straightforward and a lot of the explanations can be done through working out the homework problems. Alright, so for number 1, you were assigned A through E. I'm only going to do a couple. So first, we're supposed to find all the factors of the number and then circle the prime factors in each. And it's suggested to use the divisibility rules, which look like this. All right, the student should have this in their workbook. Okay, if they don't have it down, you can find the workbook key on the resource site. Now, you can use this like it's suggested, or really you shouldn't have to use it for any number less than 100 because we have our times table memorized. We can simply think whatever number is given to us if that is a product that is on our times table. So for example, question 1a, number 6, or we should automatically know that that is 2 times 3. All right, so along with the number 1 and 6, because every number has the factor of 1 in itself, we have also 2 and 3 as factors. Right? So 1, 2, 3, 6 are all factors of number 6. And then we need to circle the prime numbers. Now remember, the number 1 is not a prime number, nor is it a composite number. It's just a special number. So 2 is a prime, 3 is a prime, 6 is not a prime because we already saw right here it has more than 2 factors. Right? Just a reminder, a prime number is when it only has 2 factors, the number 1 and the number itself. Okay? Now, if it's not clear that 2 and 3 are prime numbers, then you would just have to work it out on the side and just to see, okay, what are the factors for 2? And that should only be 1 and 2. What are the factors of 3? That should only be 1 and 3. Right? Just to confirm that those are prime numbers. Right? But the more they work, the more they will be able to quickly recognize which one of the lower numbers are prime numbers. All right, number 1b, we have the number 11. Okay. We can go through our times table and really, I don't recall anything. Any two numbers multiplying together will give me the product 11. All right, so I'm pretty confident that it's just 1 and 11. All right, now if I want to confirm that, I can use my divisibility rules. All right, so 11 cannot be divided by 2 because it is not an even number. The sum of the two digits is 1 plus 1 equals 2, which is not divisible by 3, so 3 is not possible 1. The last two digits as a number is not divisible by 4, and I do not need to keep on going because all of these numbers will be too big. All right, one of the tricks on knowing how far you need to go is to take the square root of the number you're trying to find. So the square root of 11, we don't know what it is, but we know that it is more than 3 because 3 times 3 is 9, and it's less than 4 because 4 times 4 is 16. Okay, so that's why we shouldn't have to go past 4. And after we check 2 and 3, we'll know for sure that it does not have any other factors. All right, so 1 and 11, again, 1 is not a prime number, nor is it a composite number. 11, we just define that it's a prime number. Okay, moving on to number 1J, we're given the number 65. Okay, now right away we should be able to recognize that that's a multiple of 5 because any multiple of 5 it will either end with 5 or 0. Now that is past our times table because usually we don't memorize it past times 10. So you can go and use your rule. All right, 2 is not a factor because it's not even number. 6 plus 5 is 11, so 3 is out. it's not divisible by 4. 5, we already know it's divisible. 6, the number is divisible by 2 and 3, which we already ruled out, so 6 doesn't apply. And 8 should be the last number we have to check, because 8 times 8 is 64, and anything past that is going to be too big. So the last 3 digits divisible by 8, it's not. Now we are missing number 7 because the 7 does not have a rule, so we really should check if 65 is divisible by 7. Now again, with our times table, we should be able to know that it is not, because it's either 63 times 9, 7 times 9 equals 63, which is not 65, or the next one up is 7 times 10, which is 70, which is too high. Okay, so along with 1 and 65, we also have the number 5. Now I need to find out what will go with the number 5, and I can use long division. Alright, so 5 times 13 will give me 65. So that is my other factor that goes with it. Alright, now I just need to circle the prime numbers, which is the number 5 and the number 13. Again, if it's not obvious that 13 is prime, you would need to just go through the process to the side. 13, I know it's 1 and 13. And quickly I should be able to realize there is no other factors that will go with it. Alright. Number 2, it is asking us, oops, wrong sheet, sorry. Number 2, are there any numbers given in exercise 1 that are prime? Alright. So for 1a, 6 is not prime because it has more than 2 factors. 1b, 11 is prime. Alright, so 11 is a prime number because it only has 2 factors. Right, 65 is not prime because it has more than 2. Right, and because I didn't work out all of it, it's possible that number 2 has additional answers that go with it. Alright, number 3. Now, the key to number 3 is recognizing that any of the arrangements that have the blocks in a row automatically are not prime numbers, because the definition of the area is 1, 2 times 1, 2, 3, 4, 5. So if the total of these blocks is 2 times 5, automatically I already know 2 and 5 are factors. So over here, 2 times 3, 2 and 3 are factors. Right? The ones over here you would just need to count because it's just a single column or a single row. Then you would just need to count that this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and then find out which of those numbers are prime, is a prime number. All right. Number 4, we are given a number n, and then for each of the number we need to find all the factors, so similar to number 1, and then we're going to list them in order, which we did in number 1, and then draw a line above the list to show which factor goes with which one to form the pair. All right. So for A, we're given a number 36, and I usually like to work just on the side. 36 is 1 times 36. It's 2 times 18, 3 times 12, 4 times 9, 6 times 6. Okay, if any time that is not obvious, you can go at it a little slower by using your divisibility rules. Okay, you can go through 2, 3, 4, 5 to see to confirm that it has a factor. I mean, it's divisible by that number. All right, so since it's an even number, we know it's divisible by 2. You can either use long division or be able to do that in your head. We know that it's divisible by 3 because 3 plus 6 will give me 9, which follows the rule. All right, it's divisible by 4 because we should know from a times table 4 times 9 equals 36. and then it's divisible by 6 for the same reason. All right, it's not divisible by 5 because it does not end in a 0 or 5. All right, and the square root of 36 is 6, so we do not need to go past number 6. Okay, so now I just need to list them in order. So we got 1, 2, 3, 4, 6. And I'm going to list 6 again just because we have that other requirement of matching it up with its pair. Alright, so what that means is these are matched up together. 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Alright, number 7, we are to find a prime number between the following pairs of numbers. And we are supposed to do A, so between 100 and 110. Okay, so I've listed out all the possible answers. Right away, we can eliminate all the even numbers because of the divisibility rule for number 2. All right, any even number, meaning it's ending in 0, 2, 4, 6, or 8, can be divided by 2. All right, so that leaves us with 101, 103, 105, 107, and 109. All right, and then I can go ahead and eliminate 105 because it's also divisible by 3 because 1 plus 0 plus 5 is 6, and it's also divisible by 5 because it's ending in 0 or 5. All right, and that leaves me with 101, 103, 107, or 109. All right. Now, you can just pick one by random and then go through the rest of the list, right? Because we don't need to go past number 10, okay? And, well, if we go through the list and none of the rules apply, then we can confidently say that it is a prime number. All right, so let's say I'm going to just pick the first one, 101. Okay, so we already know that can't be divided by 2, can't be divided by 3. Last 2 digits can't be divided by 4, can't be divided by 5, because it's not divisible by 2 and 3, so 6 doesn't qualify either. 7's the only one we don't have a rule for, so we do need to work that out just to confirm that 7 is not a possible factor. Alright, there's a remainder, which means that we can't divide that by 7. 8, it doesn't qualify. 9, 1 plus 1 is 2, doesn't work. And then 10 also does not work. Alright, so we can confidently say that 101 is a prime number. Now, it's possible that these numbers are also prime. You just need to go through the divisibility rules just to make sure that none of those are potential factors. Alright, number 8, we're supposed to see if the following numbers are prime or composite, and then explain the strategies used. Okay, so I'm only going to do A and B. Alright, so we have A is 125. Alright, that's past our times table, so it would be wise to use the divisibility rules. Okay, and I can just go through my rules and see if any of these apply. Now, you can go down one by one, but at this point, the student should be able to recognize that if the last digit is 5, I should know right away that it is divisible by 5, right? So I don't have to waste time checking the other ones. If 5 is a factor, possible factor, that automatically means it has more than 2 factors. So this is a composite number. And my reasoning would be it is divisible by 5. Now you wouldn't even need to find out what multiplied by 5 gives you that number, because that's not what it's asking for. It's just asking if it's prime or composite. Alright, 8b, 321. Okay, this one, depending on if you're lucky or not, it might take a long time or it might not. Okay, divided by 2, it can't because it's not an even number. 3, if I add up the digits, 3 plus 2 plus 1, that gives me 6. Lucky us, 6 is divisible by 3, which means this is also divisible by 3. So it makes it a composite number, right? And the reasoning is because it's divisible by 3. And you can always work it out just to double check. All right, and that confirms that 3 and 107 are both factors for 321.